linear dependence and linear independence. Suppose we have total n vectors alpha 1, alpha 2, alpha n. When we will say that these n vectors are linearly dependent or linearly independent, we have to consider one relation for that. This C1 alpha 1, C2 alpha 2 plus dot dot Cn alpha n equals theta. Theta means the identity element, that is the zero element. So now check this one. Now if you put C1 equals to 0, C2 equals to 0 and Cn equals to 0, this will obviously satisfy because 0 plus 0 plus 0 equals theta, that is the zero element, equals to 0. Now you have to check, is there any other non-zero elements? That means at least one of them could be non-zero and satisfying this relation or not. If yes, then we will say this is linearly dependent, and if not, that is the only zero solution is possible for that relation, then we will say this is linearly independent. So we will say the set of vector, this set of vector alpha 1, alpha 2 dot dot alpha n is linearly independent if this relation holds only when C1 equals to 0, C2 equals to 0 dot dot Cn equals to 0. Okay, there is no other non-zero elements which satisfying this relation, then we will say this is linearly independent. And if you can find any non-zero solution, now what does it mean by non-zero solution? All of the C1, C2, Cn need not to be non-zero. At least one of them is non-zero is enough. Suppose you get one solution as C1 0, C2 0, up to Ci, this is all 0, then Ci plus 1 got suppose 5, and all the other elements are 0. This is also count as a non-zero solution because at least one of them is non-zero. So if you can find any set for which this relation is holding, then we will say this set alpha 1, alpha 2 dot dot alpha n is linearly dependent. Okay. Now for example, if we take these vectors, suppose 1 0 0, 0 1 0, 0 0 1. This is alpha 1, this is alpha 2, this is alpha 3. These three vectors. Let us check they are linearly dependent or independent. So C1 into the first vector plus C2 into the second vector plus C3 into the third vector. Now theta means the zero element, that is we are dealing with R cube as all the elements having 3 tuples. So 0, 0, 0. Now equating both sides, this will become C1 plus 0 into C2. That is ultimately 0, I am not writing it again. So it will become C1, C2, C3. This will equals to 0, 0, 0. That means C1 equals 0, C2 equals 0, C3 equals 0. That is, there does not exist any other solution which can satisfy this equation. So this set of vectors, this one is linearly independent. Okay. Now we can say take another example. Suppose we are taking 1, 2 this vector, then 2, 4. Obviously 0, 0 will satisfy the solution, that is C1 into 1, 2 plus C2 into 2, 4 equals the theta, that means 0, 0, this one. So it will become C1 plus 2C2, 2C1 plus 4C2 equals 0, 0. That means C1 plus 2C2 equals 0 and 2C1 plus 4C2 equals 0. From these two equations you need to find out the value of C1, C2. Obviously check, if you put C1 equals 0, C2 equals 0, both are satisfying. That means 0, 0 always is a solution. You need to find out that is there exist any other non-zero solution or not. So if you can check that from the second equation you can take common 2. So it will become C1 plus 2C2 into 2 equals to 0. That is, this and this are same. Now put, suppose C1 equals 2 and C2 equals minus 1. Then it will become 2. If we put on the first one, 2 plus 2 into minus 1. this becomes 0, right? That means 2 comma minus 1, that once becomes a solution, and this is obviously a non-zero solution. That means there exists some non-zero solution which can satisfy this relation. So this set of vectors is linearly dependent. Okay, this is how we check linear dependence and linear independence of a set of vectors.